right, so x or y equals 8. Again, a couple things you can think about. Does this parallel to the x-axis or parallel to the y-axis? X-axis. Okay? It's parallel to the x-axis, then your functions in terms of x and your bounds are on the x-axis. So the bounds are going to be 0, 2. Okay? Because your slices are circles this way. Okay, the other thing to think about is, if you look at it, is there going to be a hole all the way through it? That might help you think about it as well. Close, right? There's going to be, you're going to get to here, there's going to be a little tiny, infinitely small thread. It's like a window there. You'll see through it. When we rotate this thing, it's kind of like the other one was here. The outside is a cylinder, so the outside radius is constant. What is the outside radius, the big radius? 8. Big radius? 8. Okay? So, this is 8. Because we're rotating. If you look at this, it's going to look like a cylinder from the side profile. It's going to be, this is what you're going to see from the side profile. Turn like this while we're done my marker stuff. If you look down the inside of it, it's going to have something cut out again. It's going to have a hole cut out of the inside. Okay? So now I need an expression for this radius. Remember, the distance to the x-axis is our function. That is not the distance to the x-axis. So I'm going to have to combine some things. What's that going to combine to? 8 minus x cubed. 8 minus x cubed. Because this is 8 from the rotation, and then I'm going to subtract that. So it's 8 minus x cubed. Squared. Okay? Look at that. It's even. Right, draw pictures of the back and forth. Can I explain one more time? Yes. Okay, so you only have a couple things you can tell from the picture. You know the distance from anywhere on the function to the x-axis is our x cubed. Okay? And I know the distance from the axis of rotation is 8, and that's constant. So I got to use 8 and x cubed to find an expression for my radius. That's my radius right there. Because I'm cutting out. That's the part I'm cutting out. This is the big radius, and I'm cutting out a piece. Okay? So if you're going away from the x-axis or the y-axis, you're going to subtract. If you had scissors, and you needed to find this distance right here, you would start out with the piece that is 8, and you would cut out that little space, and that would leave you with your radius. Okay? If you're rotating away from the x or y-axis, you're going to use a subtractor. Okay, let's go through this and see if you follow the thinking. I think most of you are getting the 8 throwing you off because there's a gap now, right? And so I saw different people there was an 8. But again, rotating, we know that our integral is going to be from 0 to 2 because we're parallel to the x-axis. So our integral is 0 to pi. So that stuff is still the same. And it's going to be hollow. Or how do you say it? Hollow. Okay? And I think this maybe is where some people are confused because there is going to be a cylinder that's not in the middle. But it's not a cylinder everywhere. It's graduated, so it's getting wider through there. But if you look at this, you're going to see a hole in it. Okay, so the big radius is just 10. The outside of the shape is a cylinder, so the big radius is 10. So 10 squared. The outside, if we're not cutting this out, the outside is 10, no matter what. Okay? Now we're going to cut out the inside part. I still am starting with 10. The distance we know the 10, and we know that little distance right there. We have to use those to make our radius. So it's going to be 10 minus our function, 10 minus x cubed. You start to see some patterns happening, however you have to catch on to that, okay? So big radius minus little radius. If we would have been rotating around this way, we were able to just use our x cubed. But when you rotate away from the x-axis or the y-axis, you're going to be subtracting. Okay? Now, if you were to integrate this, you might notice that as you integrate that, those 10 squares are going to go away. Okay? But don't write it that way. I think it's easier to understand it with two different radius. The other way you can do this, you have a conceptual understanding, is you could say, I'm going to shift this whole thing up 10 and rotate it like an x-axis rotation. And the reason that works is because the 10s are going to cancel out. 10 minus x cubed squared is not 10 squared minus x to the 6th. Just make sure you don't do that. Otherwise, you're like, it's the same as the first one. You have a middle term in there too. We'll be doing that stuff. Okay, let's do another.
So that's the outside is the variable.
So x equals 3. The purple line up here. So after I poorly illustrated that was the horn sound, we're talking about this shape right here. Okay? This time, the outside is not a cylinder, but the inside is a cylinder. So, what's the radius of the cylinder on the inside? The radius is 1. Okay? Vertical axis rotation, so we're in terms of y, 0 to 8. Go back, big radius. So the distance to the radius is 3. The distance to the y-axis is the third root of y. So my radius is 3 minus the third root of y. Square.
I got it right.
Okay? Remember, again, that the stuff at the top of that page, you need to know that if you want to mark that on your picture, if you have something in terms of x, you know the distance to the x-axis. If you have something in terms of y, you know the distance to the y-axis. The only thing you can do is use those and constants to figure out your radius. Okay? Unless we're doing the shell method, which I don't think we're going to do. With the disk method, that's pretty straightforward. Big radius, little radius. Think about what your cross sections are and where you're slicing. What do they look at? If you looked at the end of this, this would have a hole in it. Okay? All right, let's go to number 8. Number 8 and number 5 are going to get dirty. Oh, this one's a little different. So the outside is not a cylinder, but there is a cylinder. So think about the inside is a cylinder with a radius of 1. So we're going to be cutting that out. That's going to be the subtraction part. Dx, because we are talking about a horizontal rotation. So my integral goes from 0 to 2. Saw some 0 to 8s out there. 0 to 2. Now, I need an expression for the radius. And the hard part is, you can pick values that give you a number. We don't want a number. We want it to be general. So, pick a place and draw the radius. So if I spin that one and I spin that one, I cut out that part and make that part with plastic. If I had a 3D printer, if you guys would give me that for Christmas now. Oh wait. Give me that for Valentine's Day. Owen's taking donations, $5, $10 a piece. Give me a 3D printer, we could do these and then make the actual shape. I know, so you guys can buy one for me. I don't know how much they are.
Decent ones like 600.
600? Okay, so Owen, there's about 40 some students. You're gonna need about 15 bucks a piece. Okay, by Valentine's Day, you need a 3D printer. I'll pay for the ink. Okay, anyway, side distraction. Well, the plastic is the ink. Right, but that's what, special ink is plastic. Okay. Okay, that's your plastic. Alright, so, all distractions. You know, you're all excited about what you'd make a good 3D printer. Okay, so I have this distance to here, I know. That distance is x cubed. So the radius is 1 more than that. So this one actually is x cubed plus 1 squared. Now, again, if you simplify things here, the 1s are going to go away. So if it is easier for you to think about shifting everything down 1, that's okay. I think I like the radius minus radius picture better. Okay? But like when you go to simplify this, the 1s are going to go away. Questions on that? Clarifications? Again, you know your distances. It's like saying, I have the number 10 and the number x. And I got to somehow make this distance. Well, I don't know what x is. Well, you're going to take it away. Whatever it is, you're going to take it away. Or you're going to add to it. Okay, let's just talk about this x equals -1 part. Okay? So for the x equals -1, similar question, only go in the other direction. So when I rotate across that x equals -1, the outside is going to be a cylinder. The outside's flat. Vertical. So my slices are vertical. If I'm doing something perpendicular or parallel to the vertical axis, my bounds are going to be 0 to 8 again. The outside's a cylinder. What's the radius of the outside? What's that radius? What's the radius? Demetrius, what's the radius?
Radius on 5.
On this one right here, the one I'm talking about right now.
Yeah.
What's the radius? Everywhere. What is it?
1.
What is that distance right there?
1 plus the x cubed.
The outside shape is going to be a cylinder. A cylinder has a constant radius. What is the constant radius? Because I'm measuring the outside radius here. It's the same everywhere. What's that distance? It's 3. Okay? The inside radius is that distance. That's the one where you're going to have to write a variable. And it's going to be, this is the tricky one. This is the hardest one we've done. Okay? That distance right there. We know that distance. That distance is cube root of y. It's already marked on your picture. That's not my radius. It's close to my radius. What do I got to add to that? 1. Got to add plus 1 there. So cubed root of y plus 1 quantity squared. Kind of like this one. So what kind of patterns do you see? If you're rotating across like further than the x or y axis, we add it. Okay, don't memorize that. Understand that what you want to memorize is this distance is cube root, this distance is x cubed. That's all you need to memorize. You can find constants from there. Look for a cylinder. Cylinders have constant radii. Okay?